Ladies and gentlemen, today is chapter 1, lesson 9, direct variation. Here's the thing. This is our last section of this chapter. I feel like it's really been really long. But if you think about it, it all builds on top of each other, right? So if you know how to do one thing, you pretty much know how to do everything else. And it's the same thing with today. Direct variation is just another name for keeping something in proportion, having something that's a constant rate of change. We've talked about those things. So it's going to be very simple today if you've been listening. Now here's what today is. We've been graphing, we've been making tables, and now we're going to write an equation for everything we've done. Okay? And I'm going to show you how to do that. It's really simple if you've been paying attention. All right? So here is your first vocabulary word, and it's right here. Direct variation. When two quantities have a constant ratio. Now, if you ask me, this vocabulary word is like every other vocabulary word we'd have this chapter. It talks about two quantities, constant, being in a ratio. So it's very similar to everything we've done. You can. That's just my way of showing that you've done this kind of already before, so it's not going to be something scary. So if you know what SOB is, and you know how to keep things in proportion, you know how to find if something's in proportion, that's good. But you need to write equation below and the constant. You have to also write that, and I'll explain what that is in a second. Okay, enough. Make sure you get the equation below, y equals kx, and that k is the constant. Make sure you get that, because I want to know. What are 3 ways you can tell if something's in proportion? Remember, what's one way, Aiden? Or divide, not by 2. You can divide the top and the bottom. Okay, give me another way. Cross products. Got another way, Brandon? You can reduce. Can you divide and going to come out to a decimal? You can reduce to lowest terms. Yep, so there's many different ways. You're going to want to keep that in your mind today. So equation. Your equation is y equals kx, and your constant is k. So think of, we talked about those pizzas. Remember that day we talked about those pizzas, and every pizza was like $6? Remember that? 2 pizzas was 12. 3 pizzas was 18. What was your constant? What was it constantly going up by? 6. You know how to find the constant already. Nice job. Now let me give you an example of how we're going to use this today. Okay? So they're going to give you a table just like this, and if you want to write it down, you can write it down to have an example in your notebook. So hours and miles, for 2 hours you go 130, 3 hours you're going to go 95, 4 hours you're going to go 260. Now before I find this direct variation, I need to figure out if it's in proportion or not. How can I figure out if this is in proportion? Brent. Okay, you're on the right track. Eric? Okay, so if I do 130 divided by 2, 195 divided by 3, 260 divided by 4, that would work, right? Cora? I can do cross products. I can go like this and see what happens. Yeah, all of those things. But yeah, Brent said, well, what if I just subtract? I know this is 65. I know this is 65. I know I'm going up by 1s here. That's another way. I think that's probably what you were getting at. But if I do my division, if my cross products, guess what I'm always going to come up with? 65 over 1. I'm always going to come up with that. So guess what my constant is? What is it constantly going up by? 65. Very good. So guess what your k equals? 65. Nice work. Okay, so you already got your constant. What's constantly going up by? Now my job is to write an equation. Okay, this is the part we're talking about today. This is what I said my equation was. Right? Y equals kx. Do I already know what x or k is? I know what 65, so I'm going to rewrite it like this. And that's my equation. That's it. let me show you what it means. Let me show you what the x and the y mean. Some of you are like, well, I don't get that. So if I go back up to my top here, I go back up to my table. Remember how we said if a table goes this way and this way, like your top is your x and your bottom is your y? Remember we said that? Well, if I have a table that looks like this is my x and this is my y. Okay? So let's say I want to find out, geez, if I go 10 hours, how many miles am I going to go? I can use my equation to figure this out. Well, what's in my x column now? 10. So guess where I can put 10? Yeah, let's put it in for x. What am I going to get? 650, and that's going to go in my y column. That's why this is my x and this is my y. My y is going to be my answer. After I do it, my x is what I'm going to put in. Does that make sense to everybody? We'll keep practicing. We'll keep practicing. So this means that for every 1 hour, I can go 65 miles an hour. So if I go 10 hours times 65, that means I'm going to go 650 miles in 10 hours. Okay, catching it? We'll do another one. We'll do another one. Here's my next one. Pizzas again, because I like pizza. And costs. We're going to do pizzas are $9 this time. Okay. So do I know, probably by looking at this, you already know what your constant is. What are you always going up by in this one? 9s. If you aren't sure, you can take 9 divided by 1, 18 divided by 2, 27 divided by 3. So I'm constantly going up by 9. So guess what? There's my constant already. So then I can write my equation, y equals 9x. So this would be my x's and this would be my y's. So let's say I want to find out what 20 pizzas would cost. How can I insert that into my equation to figure out what 20 pizzas are going to cost? Aiden. 9 times 20, because that in my x column, guess what? So I'm going to put it in for my x down here. It's going to come out with 180. Guess what's in my y column then? Okay, so you can use this equation to figure out how any number of pizzas that you want to buy, you can use this equation to figure out what it's going to cost. If I want to buy 100 pizzas, let's buy 100 pizzas. They're still going to be $9 a pizza. So where am I going to put that 100 now? Right here. And how much is it going to cost me? $900. It would go on this side. Cora. Well, I put it there because that's how my equation's set up. You could also set it up like this. That's the same thing. Okay, that's the same thing. Brent? Well, most likely, if it just wants you to write an equation, this is your answer. Okay? But it might ask you in your equation, it might say, okay, what does 9 mean? Well, 9's the constant. That's what it's always going up by. Okay? That might be what it asks you. Okay? All right, let's do a few more. Let's do a few more. But first, let's talk about graphs, because we're also going to talk about graphs today. Here's the thing. If they give you a graph and they say, write a direct variation from this, you have to go back to what you know. Everything has to be in proportion to write a direct variation, or an equation, okay? If you're confused about direct variation, think of an equation. Everything has to be in proportion. So if I look at a graph, how do I know if it's in proportion again? What is one thing I need to look at? David? Okay, that's one thing. What's the other thing? Oh? Okay. So looking at these two lines, which one of these is in proportion? Blue, because it goes to the origin and is straight. I can write a direct variation for the blue one. Can I write one for the red one? No, because it doesn't go to the origin and it doesn't, well, it is straight, but it doesn't go through the origin. You have to have those two. So if they give you a graph, and I'll do an example of this one too at the end, they have to go through the origin to figure it out. Okay. Questions so far? You want to do a quick one with the table again to figure out what the direct variation is and stuff? Should we do another one like that? Okay. So let's do, I don't know, what should we talk about this time? Let's do chicken wings and the cost. Okay, so for one chicken wing it costs, I don't know, $2. For 3, or let's do this. For 2, I know, but I just want to make it so it's easy for you to understand. I don't want to use like 25 cents because that's too hard. So let's do 2 costs 4, 3 costs 6, 4 costs 8. Okay, so now look at this. What's the constant? 2. So I know for every chicken wing it's going to go up how many dollars? 2, right? So my k is 2. So what's my equation then? Y equals 2x. So what if I want to buy 10 chicken wings? How can I figure this out? 2 times 10, which gives me? Okay. Questions so far? What? They're expensive. They're huge and they're the best ones out there. Okay. Yep. No. No, you're getting way out there now. No. All right, so this is another example what you're going to see in your homework today. They're going to actually give you the direct variation already. Is it in there? Use the equation, y equals 10x, represents the amount of money Julio earns for hours of work. So first of all, let's talk about this. Y equals 10x. What does this mean again? What's y mean? What's y mean? Money. And k or x means the hours. So far, so good? You see, it says it right in there. Money, y, Julio earns for hours of work. X. Identify the constant. What is the constant? 10. You're right. Is that in the place where the k should be? Yes, so that's my constant. Everybody catching it so far? Okay. Everybody good so far? Okay. What does this mean? Create a table using this equation. So let's create the table first before we figure out what it means. So let's do x and y. Let's do 1, 2, 3, 4. So if he works 1 hour, how much is he going to make? If he works 2 hours, how much is he going to make? Okay, it's going to go like this, right? Now, I want to know, what does 10 mean? What does 10 mean? Yeah, how much money he gets in an hour. That's what 10 means. Because you all told me, well, I know in 1 hour he makes $10. In 2 hours he makes 20. 3 hours he makes 4 hours he makes 40. So I know for every 1 hour, how much money is this guy going to make? $10. That's what 10 means in that equation. Okay. See what the constant is? Everybody know where to find the constant? Yes. Shake your head at me. Okay. Okay, let's do another one then. This equation, y equals 2x. So it looks like this. Represents how much it costs. So what's your y mean? Costs. To buy so many donuts. What's x mean? Yeah. Okay. My next question says, what is the constant? What's the constant here? 2, because that's the place where the k is. And I want to know what that 2 means. Yes. What were you going to say? $2 for every donut. Because if I had to make a table, what's 1 donut going to cost? What's 2 donuts going to cost? 3. Okay, what's that? Sorry. Didn't expect donuts. Okay, so time out. Time out. Do you understand what constant means? It's always going up by $2 a donut. So like what Bo said, I know that 2 means for every 1 donut, it's going to cost me $2. Okay? Do you see how everything we've done keeps building on this? We keep going back to the constant. What's it constantly going up by? That's what we're talking about today. And we're putting it into an equation. Questions so far? Anybody have questions? Okay, so I want to show you about a graph. So if you want to jot one down in your notebook, you can jot one down in your notebook. So I'm going to do hours, and I'm going to do books read again, because that's easy. Okay, and I'm going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, pretend that's straight. Okay, if you're writing it down quick, I'll let you write it down before I start talking about it. Okay, so On your homework today, they're going to give you a graph, and they're going to say find the direct variation from it. The absolute first thing you need to look at is if it's in proportion. Is this in proportion? Pretend it's a straight line. Pretend it's straight, okay? So yeah, it goes to the origin and it's straight, right? Yes, it is. It's straight. So now it says figure out my direct variation from here. So you have to think to yourself, what is this constantly going up by? 2, because for every 1 hour, how many books do I read? 2. So write your equation now. What's your equation? Y equals 2x. So what does that 2 mean in there? Your constant, but what does it symbolize? What does it mean? Yes, 2 books for 1 hour. Very good. Nice job. Can you write a direct variation? Sure, you just did. What if my thing goes like this? I can't write one. Not possible. And I know there's one like this in your homework today. You're going to have a graph like this, and it's going to say write the direct variation. Can you? No, just say no. Doesn't work. It's not in proportion. Not possible. Okay? Okay, two things I want to remind you of before you get going today. Okay? First of all, everything has to be in proportion to write a direct variation. If it's not in proportion, it cannot be done. Okay? If the graph doesn't go through the origin, it's not going to have one. We just talked about that. So think about those things. Think about what you know when you're doing this today. Read your answer or your stuff in your homework very carefully, and I'm actually going to go through it with you. So get your homework out, your notebook or your book, and go to page 85 for me, please.